Hi, my name is Bobby Craig, and today I'll be going over what is a contrast, or more specifically, why you would consider a main effect or an interaction effect, which was part of the effects model, to be called a contrast and why it fits under that definition. Okay. Uh, so a contrast, to simply put it, it's a linear combination. So it's basically a formula where you have a bunch of variables and then an equation set up to equal zero. And basically what this does is it shows you all the possible differences in your sample means. And like I said previously, this sum has to add up to zero. And that's because you're adding all your treatment means together. So say in this example where you have a 2 by 2 factorial with two possible treatment combinations, or four possible treatment combinations with two different variables. So you'd have u11 plus u21 plus u12 plus u22. Those are your four sample means, our treatment means. And then what you would do for contrast is you would subtract your population mean times however many possible treatment combinations you have. And that, in theory, should equal zero. Okay, so now we're going to look at what a main effect is and what an interaction effect is. So a main effect is going to look at how your variables in a study separately affect your dependent variable. And they're called your main variables because it's like what you're looking for in a study. So say in our previous example of a 2 by 2 factorial design, our main effects would be our two variables and how those affect a treatment mean. Uh, and then an interaction effect is kind of hidden, and it's not really something you're looking for intentionally. It's how your variables interact with each other. So if you had a study that was just one way, I'd say like four levels, that still has four possible treatment combinations, but there is no interaction effect. In a study with the 2 by 2 factorial design, you'd have four possible interaction effects: U11, U12, U21, and U22. And it's basically looking at how like there's a slight difference, how like maybe U11 is different than U12 because maybe the first variable affects the second variable differently. Uh, and how do these relate to contrasts? Simply put, they're all kind of talking about the similar idea of sample means and population. It's using sample means and population means to basically describe what the effects of your treatment means are. Okay. So when you're talking about main interaction effects, you have to use an effects model. And basically what that does is it tells you how a sample mean or a treatment mean differs from a population mean depending on which treatments are being used. So in the example below, you plug in your population average, which is mu, and then you have your main effects variables, which say you have treatments 1 and 2 for I and treatment 1 and 2 for j. So depending on which treatment you use, say it's 1 and 1, you'd have A1 and then B1. And then you would add the interaction effect between those two, which would be E11. And then the output of that would be your sample mean. And this would work for I11, I12, I21, and U22. And each of those would give you four different treatment means, which would be your results. Okay. So the main question is, how do they relate, and how could an effects model be considered a contrast? So in a contrast, you have, say, in our example of a 2 by 2 factorial, you'd have your four contrasts, U11, U12, U21, and U22, and all of those would add up to find zero. Or you'd add those up and you'd subtract your population mean times four, and that would result in zero. But for an effects model, it's not one big combination, or it's not one like big formula like the contrast is. You have to add all your effects in the population mean. Like you add your effects into a certain population mean, and that gives you a treatment mean. And so basically, this treatment mean is basically the contrast for that treatment. So say you had like y11, that basically equals mu11 because those are two sample means that you're getting when you look at the effects of variable one and variable one for your two in your 2 by 2 factorial. And if you added all the effects together, like just the effects, just like the effect of 1 and the effects of 1 and the interaction of 1 and 2, 2, of all four of your treatments, those should equal zero, just like a contrast. So basically what you could say is the mu of 1, 1, so that's part of the contrast formula, that equals mu, which is your population mean, plus the effect of your first variable, plus the effect of your second variable, which is our first possible treatment, plus the interaction between those two variables. And basically what this shows is how the first part of mu11 is part of what our contrast formula is. And then the second part of that is the second half of our effects model. So it basically goes to show that the effects model is basically just a smaller part of our contrast formula. And okay, that's it.